today, what we are going to do is that we are going to move a few steps further and extend these results to some levels so that our analysis becomes more advanced. All right. Now, as you already know, in qualitative research, normally we are interested in exploring something that has not been explored, in building a theory that can explain how some concepts are related to one another, how they are influencing one another, right? So theory building and development is the major objective in qualitative research. Now, what is a theory? A theory is just a statement that can help us, it's just something that explains how concepts or variables or codes are related to one another. So when you want to develop a theory, you should identify the relationship between the variables in majority of the cases. All right. So in majority of the cases, the theory indicates how variables or codes are related to one another. For example, in cognitive resources theory, the theory argues that intelligence and experience of people is related to their performance. Okay, so this is a theory because there are three variables or codes: intelligence, experience, and performance. And the theory just says that these two, intelligence and experience, as your cognitive resources, contribute or is related to your performance. Okay, so this is the relationship, isn't it? Now, if we want to build this theory, which explains how these three variables are related, we should go into our project and try to find what variables are related to one another. And it's very easy. If you use code co-occurrence analysis, you can find those relationships. And the philosophy or the idea behind this is really simple. If you have two codes or two variables, and you have used these two codes to code some certain number of quotations, it means that these two codes in some ways are related to one another. So if you have, for example, 200 quotations in your project, and all of these 200 quotations have been coded with performance and satisfaction, it means that logically, it is just common sense. It means that performance and satisfaction are related to one another. Does it make sense? Because you have 200 quotations. You just identify these quotations from different resources, in different contexts, in the interviews that you did, in some articles that you reviewed, right? You have found 100 or 200 quotations. Both of them are talking about performance and satisfaction at the same time. That's why you quote those quotations with satisfaction and performance. This indicates that performance and satisfaction are related to one another. It's just simple. So let's do how we can detect these relationships. Now we are just moving one step further from this process. Let me just open the project that we created yesterday. And one thing that is interesting is that despite this analysis is really advanced because we are extending the basic results of thematic analysis, but in practice, it's a very simple procedure as long as you understand the philosophy and idea behind that. So if you remember, just have a look at our project. If you remember, we had a project with 11 documents. We created 22 codes. We detected 14 quotations and coded them with these codes. So some of these codes were applied. We had some quotations that had been coded with multiple codes in this project. We created 2 memos and also 6 networks. So this is the overall statistics about our project and some more information. Now, let me just go to analyze and click on co-occurrence analysis. Okay, before I do this, let me just show you one slide and then we will talk about this. So today we are focusing on these issues, workload and work list. I think workload and work list is just 1 minute. I will talk to you about this. I will talk about this later. I first start with code co-occurrence table, which is easier because it helps us to understand the relationship between variables or codes. Then we continue with code document table. Then I talk about word cloud. Then we go to query. So this is the interface of the software for co-occurrence analysis. Let me just make it a little bit bigger. It's not full screen, isn't it? Let me just ask my colleague to just make it a little bit bigger so that we can see. Can you make the screen, can you make it full screen?
Yes. Yeah, I see them.
All right. Okay, so while my colleagues are trying to solve this, let me just explain to you. Co-occurrence analysis is just a table. The rows are the codes and the columns are also the codes. So the intersection between these columns and codes indicate the number of the quotations that have been coded with both codes in the row and also in the column. Sorry, can you just make that full screen? Yes. No, but there, yeah, and on the screen. Okay, that's good. Thank you so much. All right, now as you can see here, we have one table. This is the code co-occurrence table. You can simply select the codes to be displayed as columns and any other codes to be displayed as the rows. So if you look at here, you can see that we have some values here. 3. 3 here means that there are 3 quotations coded with code B and code A, right? So look at this, what we have. Look at this column. Look at the header of this column. We have A, and under that you can see the value of 3. 3 means that in the entire project, there are 3 quotations coded with code A. Here, for B, you can see that in the entire project, we have 4 quotations coded with B. It's just simple. We have the same thing for the rows. For example, look at this. We have, for E, we have 2 quotations coded with E. Now look at here. This value of 4 indicates that there are 4 quotations coded with B and D, right? So this means that there is a relationship between these 2 codes in some ways, because we have 4 quotations coded with both of them. Does it make sense to you? So basically you can argue that the relationship between B and D is much stronger than the relationship between, for example, F and G, because this value is 1, you only have 1 quotation coded with F and G, but here you have 4 quotations. So this is a stronger relationship. So what you can say in your qualitative analysis, you can say that I identified a relationship between code B and code D. All right. So then after this, based on the nature of these codes, for example, one of them is a kind of behavior like leadership behavior. The other one is a kind of maybe performance related variable like achievement. So you can see that between leadership behavior and achievement, there is a relationship. And then based on the concepts of these, you can even determine the direction of causality, whether leadership behavior is causing achievement, achievement is causing leadership behavior, or they are just related in some ways and there is no causality here. So based on the code and also based on some theoretical and empirical evidence, you can even determine the direction of causality. And the good thing is that when you click on any of these cells, the list of the quotations are displayed here on the right-hand side of the window. So it's really simple. The idea is that the more quotations coded with two codes, the stronger the relationship between those two codes. Is it clear? Now let's go to the software and try to do this. All right. So to go to code co-occurrence analysis, you need to go to analyze and then you have to go to co-occurrence analysis. When you select this, you can see there is a panel here for the codes to be selected, to be considered as column codes, and also another set of codes, the same codes, to be selected as row codes. So let's just select a few of them. I select this one, so you can see that it is transferred here in this area, because this is the area where the table is created. I select BP, I select maybe DD, and I select, here I select another one, maybe FF, maybe HH, maybe this one, and this one. All right. Now you can delete this because sometimes there are a lot of codes and you need a bigger space to create this table. So you can just click on show list here so that it is not displayed here. So you have a bigger space for the table here. Is it clear? Now you can again click on that to see the list of the codes and include some other codes if you want to. So it's where you can simply add codes to the columns as the columns and also as the columns and also as the rows. All right. Now, what we have here is that we have 4 columns, 4 codes here, and you can see the number of quotations coded with each of these codes. We have the same situation for the codes as the rows. And you can see that here there are some cells that are empty. What does this mean? It means that there is no quotations coded with both codes, right? So when I click here, it means that it's 0. It means that there is no quotation in my project coded with code BB and I3. Is it clear? You can remove this by clicking on this remove empty button, so that all the codes that there is, all the codes that doesn't have any relationship with other codes are removed from the table, so that you have the table full of information. So empty cells are excluded now. Is it clear? Now, look at here. If I click on this 4, you can see the 4 quotations coded with both codes here, right? These are the 4 quotations, this one, this one, this one, and this one. So this is the first one, this is the second one, this is the third one, and this is the 4th one, right? Is it clear? And also there is one value in parentheses here in front of each of these codes. Have you ever heard have you ever heard of correlation analysis in SPSS? Correlation analysis. Correlations means relationship between variables. in a statistics correlation. When we say that two variables are correlated, it means that there is a relationship between them. All right? So correlation analysis is a statistical technique. And this correlation, in correlation analysis, there is one value that indicates the strength and direction of relationship. All right? We call it correlation coefficient. This value is between -1 to +1. So when it is close to 0, it means there is very weak or zero relationship between these two variables. When it is close to 1, it means that there is a positive relationship between the two variables. When it is close to -1, it means that there is a strong but negative relationship. So if I want to demonstrate positive and relationship, I can use my hands. So it's easier for you to understand. Look at this. This is one variable or code. This is another one. Positive relationship means that if this variable goes up, this one also goes up. If this goes down, this one also goes down. So they have the same direction of movement. This is positive relationship. Negative relationship means that this one goes up, this one goes down, or this one goes down, this one goes up. This is a negative relationship, right? So normally the coefficient for this relationship is negative because they are moving in opposite directions. No relationship means that no matter this one goes up or goes down, this one doesn't change, doesn't move. So it means that regardless of the movement of this variable, this one doesn't change, right? So this is a zero relationship. So it means that these two variables are not related. So here in the parentheses, you can see a value that is similar to this coefficient, correlation coefficient. But unlike correlation analysis, where you can have a negative correlation, here always it is a positive value. So it's always between 0 and 1. How you can determine the correlation is negative is based on the codes itself. So for example, if AA is performance and ZZ1 is maybe anxiety, theoretically we know that anxiety and performance, they are not moving in the same direction. They are always opposite one another. Am I right? So despite this value is 0.43, we know that the relationship is negative. We know it from theory and practice because obviously anxiety and performance, one of them is a positive concept, the other one is a negative concept. Am I right? So you can even determine the direction of causality. I mean, not the direction, I mean the state, whether it is a negative relationship or a positive relationship. All right? Is it clear? So you can see that in our study, what we have, despite we have completed the process of thematic analysis, you can see that we also found a strong relationship between AA and G and also between AA and ZZ. If I click on any of these, you can see the quotation here, right? So this is correlation, so this is relationship analysis in the context of qualitative data analysis. Now we have managed to develop a hypothesis. What is our hypothesis? There is a positive relationship or a negative, there is a relationship between AA and G. Because I told you, codes in qualitative research are equivalent to variables in quantitative research. So when you identify in your data, when you identify a relationship between these two codes, it means that you are developing a new hypothesis. So what is a hypothesis? A hypothesis is just a statement which indicates how two variables are related. So this is our hypothesis that we developed in this research. What is our hypothesis? There is a relationship between AA and G. Does it make sense? Now, if there is, for example, if I am a quantitative researcher, you are a qualitative researcher. You developed this hypothesis. Now what I can do as a quantitative researcher, I create a survey, I collect data for AA, I also collect data for G from some people, then I use a statistical analysis, the correlation analysis, to test what you have proposed as your hypothesis. So this is the process of theory development or hypothesis development and theory or hypothesis verification or testing. In qualitative research, we build theories and hypotheses. In quantitative research, we test and verify the hypothesis. Is it clear? All right, so this is how it works. If you want, you can export this table into Excel, and this pass coefficient, this correlate coefficient is displayed because I have already selected show coefficient. So if I deselect that, you don't see the coefficient here. But this coefficient is helpful in some ways because it can just indicate the strength of the relationship between these two. So 0.57 is much larger than, for example, 0.2. And this means that in your study, the relationship between AA and G is much stronger than the relationship between E and G. Does it make sense? Also note that sometimes there are overlapping quotations. I mean, there is one quotation coded with both. I mean, how to say, one quotation embedded in another quotation. So sometimes, you know, despite you can see that there are 4 quotations here, but when you click on here, you can see that here only 3 or maybe 5 is displayed. It is just because there are some overlapping quotations or quotations embedded in other quotations. I mean, you can simply identify that. It's not a big issue. So the main concept here is that you can explore the relationship between the codes and develop new hypotheses about the relationship between the codes so that quantitative researchers test your hypothesis. Very simple. Is it clear? Very good. Now let's go to code document analysis. All right. Remember, let me just explain something to you. In quantitative research, normally the methods of analysis are categorized into 3 main categories. One of them is relationship analysis, like what we did using co-occurrence analysis and correlation analysis in spaces, for example. Another type of analysis in statistics is comparison analysis. Normally in statistical analysis, we are interested in comparing groups in terms of different variables, in terms of anything. This is comparison analysis. So we compare 2 or multiple groups in terms of 1 or a few variables. This is comparison analysis. We also have prediction analysis, which is to some extent related to correlation analysis. I don't want to talk about that. But comparison analysis is another statistical method to test the theories which explain how groups are different in terms of variables. So normally in quantitative studies, we want to test the theories that explain the relationship between variables, or we want to test the theories that explain how groups are different in terms of variables. So these are the 2 major areas of statistical analysis. So in other words, if I want to test a theory that explains how groups are different in terms of a variable, certainly a qualitative researcher must develop this theory so that I can test it in quantitative research, right? If there is no theory about how groups are different about a variable, how I can test that? So there should be a theory so that I can test it in quantitative research. right? So as a qualitative researcher now, we develop a theory that explains how groups are different from one another using code document table. Each document will be a group, or I mean, it could be document or document groups, and the variables could be variable codes or codes groups. So you can simply compare documents across codes, and then this just gives you some idea about the differences between groups. Now look at this slide. If you look at this slide, again, it is a small. I don't know how she changed it to be bigger, but never mind. Let me just do this. How I can remove this ribbon? Where is it? Previously, you could remove. Oh, it's here. Yes. Now at least it's bigger. Yeah. All right. So look at here. What do we have? When you click on code document analysis, what you have is that you have the list of the codes and code groups here. Here in this example, there is no code group to be displayed in this panel. And also document and document groups, right? So there are 4 panels here. Codes and code groups, documents and document groups. Is it clear? Now, when you select, you can select documents or document groups to be displayed as columns, and codes or code groups to be displayed as rows. Now look at here. We have let's assume that we want to develop a hypothesis that explains differences between people in KL and Penang, right? We want to compare KL and Penang people in terms of a few variables, right? So when you select this, you can see that we have 5 quotations, all right, for group KL coded with code change, but here we have 1 quotation coded with change for the group of people in Penang, right? So what does it mean? Does it indicate that change could be more important for people in KL compared to people in Penang? Or there is a difference in the perception of people in Penang and KL about the concept of change? Does it indicate this? Obviously, yes. So here you can see that there is a difference between people in KL and Penang in terms of change, and ratings possibly for KL group is higher than the ratings for Penang group. But how about commitment? There is only 1 quotation in this group, also 1 quotation in this group. It means that when you interviewed people in Penang and KL, only 1 time it happened that they talk about commitment. So it means that there is no commitment is not important for them, or there is no difference between people in KL and Penang about commitment, right? Because you can see that both is 1. You can also see a difference between the code Edison and also electricity between people in KL and Penang. And also look at here, under this column, you can see there are, under KL group, you can see that we have 4 documents. It means that to build KL group document group, we used 4 documents. To create the Penang group, we use 3 documents. So we have 3 documents in our project which contain the data we collected from Penang. We have 4 documents in our project which contain the data we collected from people in KL. Is it clear? Now, something that is important here is that, and also look at the quotations. There are 15 quotations in all of these 4. There are 5 quotations in all of these 3 documents. Does it make sense? Now, in a statistics, when you would like to compare groups, samples should be of relatively equal size. This is important. You cannot, statistically, you cannot compare a group of 10,000 people with a group of 50 people. It's meaningless. Sample sizes should be of relative equality. Does it make sense? They should be equal to some extent. Now, this comparison is not meaningful. Why? Because here our sample size is 15, here it is 5. We have 15 quotations, we are comparing 15 quotations with 5 quotations. Am I right? So sample sizes here are not equal. So we have to normalize this, and I will show you how it can be done so that our comparison becomes meaningful. All right? So in this analysis, what we managed to do, we managed to develop a hypothesis that explains how, to what extent people in Penang and people in KL are different in terms of a set of codes or variables. Of course, I told you in this example, this comparison is not meaningful because sample sizes are different in 2 groups. Here we have 15 quotations, and we are comparing the 15 quotations with 5 quotations. So basically, there is a problem with this analysis, but I will show you in practice how you can take care of this problem. So we managed to develop a theory that explains how groups are different in terms of variables. And now we can pass this theory to quantitative researchers, and they collect data for change, for commitment from people in Penang and KL, and do some t-test analysis or ANOVA analysis or any other types of analysis that is related to comparison, and then test our hypothesis. So we developed a theory or a hypothesis that explains how 2 groups are different in terms of codes. Is it clear? Yes? And again, if you just select any of these codes, the quotations are, if you select any of these cells, the quotations are displayed on the right-hand side. So let's just go to the software and have a look at this analysis. I just close this, I go to code document table. Here you can see all of the codes and code groups that we created, right? And the documents and document groups we created. Am I right? So let's assume that we would like to compare people in similar example in Penang and in KL, or maybe male and female. I can also include male and female. So I select 4 groups. I want to compare them, but obviously I want to compare female with male and KL with Penang. So I add everything as the columns of this table. Now I want to compare them in terms of maybe this variable, in terms of this variable, in terms of this variable, this and this variable. These 3. Is it clear? Now I'm just going to click on show list so that I have a bigger place here. Now here let's focus on Penang, let's focus on female group and male group. All right? Now let's focus on male group and female group. Under female group, I have 4 quotations. Under male, I have 10 quotations, right? So basically, the comparison here is a little bit problematic. Why? Because the quotation numbers are different. Let me just exclude KL and Penang, make it a little bit easier for you to see, and then we'll talk about KL and Penang as another example. Look at here. Here we have 10 quotations. Here we have 4 quotations for male and female people, right? In terms of these codes. And also you have these values. I mean, 3 plus 4 is 7. Here 3 plus 1 is also 7. So you can basically see the totals for rows and columns, right? And this is the grand total, 16 quotations. If I click on any of these cells, you can simply see them here, the number of quotations. So here we have 3 quotations, you can see them. There are 4 quotations now. Here you can see them. Here we have 1, you can see that. Here we have another one, you can see that, right? If you click on any of the cells, you can see the quotation on the right hand side. Now, thus, basically, can we say that there is no relationship between female and male students in terms of this variable DD? Can we say that? Right now, we can say that. Why? Because there is one there is one quotation here, another quotation here. So basically, there is no differences. But the problem is that here we are comparing 10 with 4. So we have to normalize this to better understand the difference. How we can do that? We go to settings and then we select normalize. We go to setting and we select normalize. Now here you can see that the values have changed, right? Can you see that? Let me just, you can maybe select, you can look at the screen first and then I just maybe give you some time to do it. I remove normalize. These are the values that we have. If I select normalize, what happens is that the values in the table are adjusted regardless of the number of quotations in each group so that comparison becomes meaningful. Is it clear? Yes? Now, here you can see that the value from 1 has changed to 1 from 29 because it is normalized. Now, it means that it is a more valid value to make comparisons. But obviously, there is not a big difference between male and female students in terms of DD because these values are very close, isn't it? If this value was 5 and this value was 1.29, we could argue that DD, I mean, there is a difference between male and female students in terms of DD. But now we cannot make this hypothesis. We cannot develop this hypothesis because these values are very close. If the difference is quite big, then you can develop the hypothesis which indicates the difference between the two groups. But here in this example, you can see that there is not a big difference. Let's just try to add some other codes to this to see whether we can see any differences. Maybe here for C, look at this, or maybe E. Can we argue that there is a difference between male and female students in terms of this variable E or the code E? Yes, because here we have two quotations, here there is nothing, right? Of course, the difference is not very big. The gap is not very big, but you have observed some differences, right? So we can develop this hypothesis that there is a difference between male and female people. We have also normalized everything, so you can see that the number of columns, I mean the number of quotations, have been adjusted. They are equal now. If I remove normalize, you can see that they are different. We are comparing 13 with 10, right? But we just normalize this so that the values are adjusted and the comparison becomes meaningful. We can also argue that there is a difference between male and female students in terms of C, because here it's 4, almost 4, here it's 2. So maybe you can say that there is a difference here. How about AA and BB? Their values are quite similar, so obviously there is not a significant difference between these two groups. And also for DD, we have the same situation. Does it make sense? Did you understand that? So let's do another example. This time we focus on maybe male and female. Of course, I told you you can select multiple groups, but to make it easy to understand, I just select 2 groups. You can change the variable. You can even add variable code group. I mean, not only codes, but also code groups. So I just add some code groups here as well. Now look at this. We are comparing 2 groups. The values are normalized, so comparison is meaningful. Look at here. Not a big difference between KL and Penang in terms of AA. Also, a little bit of difference between KL and Penang in terms of BB. A little bit of difference between KL and Penang in terms of C. A big difference in terms of D. No differences in terms of E. Almost no differences in terms of code group A, but in terms of code group B, you can see a big difference, right? So what is our main hypothesis here, focusing on code group B? We can develop this hypothesis that there is a difference between Penang and KL people in terms of code group B. Code group B could be anything. It could be satisfaction. It could be anything. I just used some generic labels for the codes and code groups, if you remember from yesterday, right? So we managed to develop hypotheses that explain differences across groups in terms of codes. Is it clear? Yes?
Question. You have mentioned that there are some differences in some codes and there are not differences in another code. So what is the threshold of difference or not difference?
The number of the quotations here. I mean, but there is a big difference. Look at here, we have 5 quotations here, we have 1.16. So these two values are very different from one another, isn't it? So it means that we have 5 quotations related to code group B in Penang group, but we have only 1.16 quotations. Of course, 1.16 doesn't make sense, but it just helps us to better do the comparison because we are normalizing everything, because sample sizes are not equal, you know. So as long as there is a difference between the values in the columns, you can develop a hypothesis which indicates the differences. And another hypothesis basically is this. Look at this. Your hypothesis could be something like that. There is not a difference between KL and Penang people in terms of B, in terms of E. So you really don't need to find big differences. You can also develop a hypothesis that indicates there is no difference. This is also another hypothesis, isn't it? So your hypothesis could be this. There is a difference between people in KL and Penang in terms of this variable, or there is not a difference between these people from these cities in terms of this variable.
So there is a specific number of the threshold?
It's just, I mean, you just look at this and I cannot tell you that if this is, for example, 5 and here is 2, then there is a difference. This is just something that you are proposing, you are developing a hypothesis. It should be tested later. But when the people want to test something, they should have something in their hand to test it. So you are providing the material for quantitative researchers to test something. What you observe here is just based on your data. You are proposing a hypothesis. You are developing a hypothesis. It doesn't mean that when you collect data from a big group of people and test this hypothesis, maybe we fail to find support for this. But at least in your qualitative research, you are done with your job. You can proudly say that I did thematic analysis yesterday. The basic results are here. I moved one step further and developed hypotheses that explain the differences between groups. To what extent they are supported is not my job. Quantitative researchers should collect data for this and test this. If they find empirical evidence in their quantitative research for this hypothesis, it means that you have done a very good job because your hypothesis is supported by them, has been supported by them. If they don't find support for this, it means that you did a good job in terms of extending the basic results, but your hypothesis is not working. So quantitative researchers must, now it's their job to find reasons why this hypothesis that is well developed by you is not supported. So they should provide justifications for that. It's not your job. Your job is to develop this. As long as your data is telling you, using this table, is telling you that there is a difference between groups, you develop your hypothesis and you are done. You don't care about what happens next because quantitative researchers should take the lead and find data for the variables or the codes, make comparisons between people in KL and Penang, and then verify the hypothesis that you developed. All right? So your responsibility is to develop the hypothesis, finished. If it didn't work, it's not a big issue for you. I mean, this is not your job. This is quantitative people job.
Yeah, understood. Thank you, sir.
No problem.
So these code concurrence analysis and code document should be just adopted when we are doing ground theory, or can
Mainly, that's a very good question. You know, we have a wide range of
approaches.
designs, research designs for qualitative research approach. And if you really want to develop a theory, you should use grounded theory research design and follow those steps to develop a theory and just do all of these. But you should, the guidelines are the guidelines provided by grounded theory research design. So you have to follow all of those guidelines to come up with this. But even if you do case studies, or even if you follow other research designs like case study ethnography, as long as you have quotes and quotations, you can use this table to further extend your basic results. It is you have not considered maybe all of the principles of grounded theory research design, but still it makes sense. I mean, no one will criticize you if you talk about this, you know. And also there is a big overlap between the guidelines of, for example, grounded theory research design and case studies, because all of them involve thematic analysis, and so it's not a big issue.
It's an optional thing.
It's something that can, I mean, further extend your basic results. Even you can do a case study, you come up with this, and then at chapter 5, you report that I did a case study. You reported yourself maybe as a limitation or something like that. You can report that I didn't follow the grounded theory research design, but I did a case study and I used this table to further extend my results. So this is something that I want to report in my thesis or in my article. And still you are in the safe side. Any questions? Yes.
Doctor, would you introduce some papers using this method, published papers using this method, or only a method we can make our hypothesis?
You know, unfortunately, researchers these days tend to be a little bit lazy.
Yeah.
And their main objective is to increase the number of publications, not to increase the impact of their research. So a typical researcher, when he or she does the basic thematic analysis, he wants to publish as soon as possible, because of course there are a lot of KPIs, promotion criteria, a lot of other things, you know. So sometimes, you know, they are lazy, tend to be lazy. Sometimes they have no choice. They are forced to publish as soon as possible. So sometimes they don't spend time to do this. And that's why you cannot, I mean, you can find this type of analysis in some articles. I haven't seen that, but it doesn't mean that it is not something good to do. There are some other reasons behind that. But if you do this, everybody will admire you. Even when I evaluate PhD thesis, qualitative PhD thesis, for example, I evaluated one PhD thesis from Sunday University. The student had done qualitative data analysis, but I could not see all of this. And that's why I raised a lot of issues. I asked him to correct everything, even about the importance of, one of my comments was that which of these codes is important in your research? The one with higher number of frequencies. And I explained to him in my comment report, I explained everything to the student so that he could correct and improve the thesis. For my own students, they always consider this. So if you want to see this, for example, you can go to, one of my students has his Viva in 10th of March. and he did qualitative analysis using ATLAS.ti, and I asked him to take care of code document, table, and also co-occurrence analysis, so you can refer to his thesis later. But the problem is that when we're talking about publications, it is highly possible that there is no quality in the published papers. I just give you one example. A few years ago, let me just show you this article. A few years ago, I wrote one article which is about the application of PLS STEM analysis in higher education research. And I wrote this with this guy, Professor Ringel. Professor Ringel is the most well-known person with over 150,000 citations, something like that. He's the most well-known person in PLS. He's also a close friend of mine. We wrote this article and we reviewed almost 49 papers, if I'm not mistaken. Yes, we identified 49. Yes, we reviewed 49 articles published in a Scopus Index, and let me just show it to you, in very important journals, as you can see here. Higher education, the most important journal in higher education, studies in higher education. So all of these are very important journals. And to our surprise, we didn't even find one single article published in this. I mean, we did not find even one single article out of these 49 in which all of the standard basic steps of doing PLS has been followed. Even a single article. So what I want to tell you is that papers are published, but to what extent you can see the quality, it's something else. This is just one indication that publication necessarily doesn't indicate the quality. All right? We didn't find, some of these papers have been published with very well-known people, but they also didn't follow the basic steps. Now we are talking about extending the basic results of qualitative or thematic analysis. Just imagine how hard it could be to find high-quality papers in which they have focused or touched these areas. But if you do this, I personally will admire you. I will tell you that you have done a very good job. And when I say this to someone, it really means a lot. All right? So just consider this, extend the basic results. Even though it's a very advanced type of analysis, because you are extending the basic results and you are developing hypotheses that statisticians can test for you, but it's not difficult. It's just a few simple steps. All right? So you can do this. You can expand the results of the basic results of your thematic analysis very easily. All right. Any questions? People in the room? Yes, no? Again,